So we're going to begin our study of the analytical methods for evaluating limits, and we're going to begin with direct substitution. So when we are not provided a graph, we have several approaches to take, but direct substitution should always be the first approach. Direct substitution, we simply evaluate the function at the value that theta or x is approaching. So in this case, the limit of tangent of theta as theta is approaching pi over 4 is going to be, or 5 pi over 4, is going to be the tangent of 5 pi over 4, and we know that that's 1. So for part B, the limit as x approaches negative 3 of x squared minus 5 is going to be negative 3 squared plus 5, which is, I apologize, that is minus 5, so let's fix that. So negative 3 squared minus 5 is going to be 4. Your limit as x approaches 5 of 9 is simply 9. And lastly, our limit as x approaches 6 of negative x plus 5 to the 1,000th power is going to be negative 6 plus 5 to the 1,000th power, which is going to be negative 1 to 1,000, which is just going to be 1. So this process should be your default point, starting point, when you're evaluating finite limits. And it fails if you are dividing by 0, so that's, for example, 9 over 0. If you are taking the square root of a negative number, you are evaluating a function at a value not in its domain. For example, the limit as x approaches pi over 2 of tangent x, or the limit as x approaches 3 of x plus 5 over x minus 5, or x minus 3. Or anything else that breaks a basic rule of math. In addition, if you end up with not a 0 over 0, that's going to behave differently than 9 over 0, and we will cover that. So then you need to do some basic algebraic simplification, and that's going to be the next few videos. So we have factor and cancel, multiply by the conjugate, or trig substitutions. The key point here is if a function is continuous on its domain, it can always be directly evaluated for values that then generate an output.